Okay, now let's proceed sa atong main topic na gyud no on our module 15, that is the relationship of work and the energy. So, okay, we have a particle that is shown here. So as you can see, this is moving in a curvilinear motion. So in a curvilinear motion, we have three components, but here shown is the two components of the curvilinear motion. You have its tangential component. The tangential component of the curvilinear motion, or the path of the particle, is always tangent to the path of its motion. Same with its acceleration and the velocity. Then we have also here the normal component of the velocity. The normal component of the particle. So we have the normal component of the acceleration here. So let's say we have a force applied to this object. So we have an inclined force here. This is the summation of the force. And then we have a force, tangential force, and then the normal force. So say gamito na to nga force ani nga particle. So again, that is moving in a curvilinear or in a curved path. So if we have a force of a particle moving along a curved path, so this is the motion direction of the motion. So we have a force here, tangential force, and then we have the normal force, and then we have the summation of the force here. So if we have an applied force here, this is the we have an angle here, theta. So say gamiton nato nga force, atong gamiton nga force is katong force nga towards the motion. So ang force towards the motion is the tangential force. So ang total work done nato, di ba? Our total work done for this is just the tangential force, and then let's say we have the first position here and then the final position. So we have a displacement. Let's call the displacement ds from the first to the second. So this is our work for this particular sample. So if we write the force, the summation of the tangential force, since we have an acceleration here, this is a moving particle applying the Newton's second law of motion. We have the mass times the acceleration, tangential acceleration. Now, namatay velocity here, di ba? So, if you remember, we have a relationship with acceleration and velocity. Acceleration is the change of velocity with respect to time, and then the velocity is just the change of the displacement ds with respect to time. And then, kung ato nang i-simplify, solving for dt, so we have dt is equal to dv over the acceleration. Same gyapon for the velocity, we have dt is equal to the ds over v. Equating the two equation, we have dv over a is equal to ds over v. Or v dv, kung ato siya i-cross, we have v dv is equal to ads. So solving for s, the acceleration, we have v dv over ds. So kung ato ning i-substitute, here we have summation of the forces, t is equal to mass times v dv over ds. If we cross that ds here on this side, on the left side, we have summation of the total force ds is equal to mv dv. Now, if we integrate both sides, so here from S1 to S2, here from, so this is dv, so from initial velocity to its final velocity. So this side here looks similar on this side. Sa ato pa, summation of the total work done is equal to kani siya. So unsa may integral ani, we will have 1/2 mv squared from v1 to v2, or the summation of 1/2 mv sub 2 squared minus 1/2 mv sub 1 squared. So does this look familiar? So this equation here, if you remember, we have the kinetic energy. Ang symbol ni kinetic energy is T. So kinetic energy is equal to 1/2 mass times the square of the velocity. Sa ato pa, ang total work done di ay sa usa ka particle is just the change of the kinetic energy. So ang change sa kinetic energy mo na siya 1/2 m final velocity squared minus the initial velocity. mv1 squared. So if ato siya i-summarize, since ang T symbolize the kinetic energy and then U symbolize the work, so ang total work done di is equal to T2 minus T1. Okay, it is important to remember this formula. Or the total work done or total energy nga nahitabo sa usa ka particle from the work energy relationship is the initial kinetic energy plus the total work done on a particle is just equal to the final kinetic energy. So we have here the initial kinetic energy and then the total work done and then the final kinetic energy. So mao din ilang relationship. So it is important to always remember this equation, no? Ang kinetic energy is just the initial kinetic energy plus total work done on a particle is just equal to its final kinetic energy. So gamit jud kay ni siya sa ato ang further nga problems. So this is the relationship of the work and energy. Aside po, you can write that as the total work done is equal to T2 minus T1. So ano ada? But importantly, you remember this formula. Okay?